Hey guys and gals, hey guys and gals, what is good? What is good? How are you doing this fine day? Let's go! Yeah. Yes. Another fine, beautiful day. Another fine, beautiful day. Let's go. How you doing, guys and gals? Thank you for hitting that play button. Thank you for checking out the content. Much love for that. Turn it up, whoever you are. So awesome of you. Quickly, want to thank supporters and followers of the channel. Oh, much love. Every single one of you beautiful, intelligent people. 120 IQ Club, let's go! Excuse me. Yes. Every single one of you, thank you for the support. Thank you for the recent follow. Wicked Stats. Turn it up. You snuck that one in. I didn't even hear it. My notification sounds, I just don't get them. Like, I know when I watch the stream later, I can see the my alert box, but I don't see it here, right? I can't see it on my screen, but if I'm watching the stream, I don't know, like, how does that work? I thought I could see that stuff. I get no sound. But quick shout outs to Wicked Stat sneaking in with that follow. Probably my motivation stream. I don't know. Streamlabs is broke. I do all my tweaking and adjusting and all that stuff. You know, software adjusting, tweaking, okay? Nothing else more than that, guys, okay? Say no to drugs. Unless it's the green kind, that's fine. That man-made stuff, stay away from it. That's my advice. Anything man-made, no bueno, no bueno. Not the good for you. No, no, no. Okay, what am I looking for? Get with the program, Batman. Get with the program. Bad mod. Bad mod. I'm gonna fire you. Oh yeah, that would mean I would be firing myself. Wicked stats, alright? I just want to quickly make sure I have that so I show you out every time. That's amazing. Amazing! I'm going to drop in a yerp. Okay, quickly going to shout out every single one of you recent followers over the last month or so, since I've been kind of back to streaming here on Twitch. It's great to have you guys and gals. Thank you for the views. You guys are beating YouTube, every single one of you. Just let you guys know here in Twitch land, you're kicking YouTube's butt in the views. What's up, YouTube? What are you guys into over there? Sorry, Twitch friends, for turning my back on you guys. It's 600 plus followers. You know, you guys are stuck around, didn't quit on me. Majority of you, every single one of you solid people. I love it. Yeah, I love it. I don't know. I'm trying to figure out, like, I don't know. I'm just going to keep my opinion to myself, but I'm just going to say, like, what's up? What's up, YouTube? What's up? So it's great. People on Twitch, you brothers and sisters are awesome. Every single one of you. Thank you for the support. Legends. Quickly. Let's shout out Nicole Trace 66. Bart number 1. Bart, you're number 1. Let's go. Jim Jam 1238. Kazards 20. Gavin 555. And Kamikaze ML. Okay, Kamikaze. Please don't kamikaze, okay? I love having you around, bruh. I love having you around. You're my brother from another mother, man. Okay? Please don't kamikaze yourself. I want you here. Because I love you, man. I love you. As a person, as the individual that you are. Kamikaze ML. Let's go. Quick shout outs also goes to iDucky. iDucky. I love it. I need the quacks a little bit quicker. That's too slow. Fix your quacks. That's for Ducky. Ducky. I'm assuming it's I don't know. It's a pipe. It looks like the pipe symbol on the keyboard. It's right above your enter button. I call it a pipe. You know, kind of like a Mario pipe. Think Mario pipe. All right, guys. Nothing else. Well, yeah. We'll just leave it at that. And let's finish off with a recent follower on the stream. Probably last stream. But today, it happened. Wicked Stat! Let's go, turning it up. Appreciate you guys and gals. I truly do. One last thing, and then we're going to get into learning, because learning is growing. I love learning. Okay? I'd rather be, I love Bob Barker and everything, but I don't want to become one of them, and no offense, elderly people, but I don't want to become, one of those boob tube starers, staring at the boob tube, watching Bob Barker. I'd rather be learning, keeping the mind fresh, keeping it fresh. That's right, keeping the mind fresh. I don't want to become one of them TV NPCs literally in zombie mode, drooling, staring at a TV, drooling on a couch. No offense, elderly people, I love you too. I hope you had a good life, 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 a good life. I guess I'm in one of those moods today. You guys love it though, don't you? I should be in this mood all the time. Okay, all right. Here it is. Once I find it, here it is. Okay, here it is. This is for you guys and gals. Every single one of you followers, supporters. Whether it's on Twitch and YouTube, I do appreciate you YouTube supporters, okay? Anything I say doesn't reflect you guys, okay? You guys are already awesome in my books because you hit the old follow, subscribe button, okay? I already know you're fresh. Let's go. This is for you. That's right. That's for every single one of you supporters, followers here on Twitch and also on YouTube. Much love. Thank you for the support. Okay, I think it's time to learn, guys and gals. It's time to learn. Let's keep it going. Man, it's so awesome that you guys want to learn C++. Man, it's great. We're making it easy over here, okay? That's the idea. You're kind of getting like full-blown lectures. You can turn these into audiobooks if you want. It's up to you. I mean, if you could timestamp it somehow, but there are points in the video you might want to see the code that I'm typing up in Windows Studio. So it's up to you. However you want to do it, whatever works for you for learning. We're all different, guys and gals, okay? Excuse me, we all have different ways of learning. There are people that are visual learners. There are people that learn by feel and touch and just taking things apart or doing whatever they do. And then there's auditory learners, right? Listeners, those that listen, right? We all have different qualities and attributes, and we even learn different ways. Okay? That's just, not to go on a tangent, but that's how we're created, okay? Open your eyes, okay? Open your eyes. All right? Bet you believe in ghosts. Bet you do. All right. I'm trying my best not to go on a tangent here, but let's get to learning. We're still continuing with integers. There's a little bit more, right? The different data types we still have to learn, guys. I know I've brought it up, I've talked about them and such. Actually, you know what? Now that just reminding myself to check the stream quickly, make sure we're good. Pretty sure we are. Yes, we are. Awesome. It's great to have you. I don't normally keep the stream up because, I have a bit of an understanding kind of how the internet works a little bit, right? I'm streaming upstream right now, and I don't want to be streaming downstream at the same time, right? Make sense? Well, I'm not really streaming downstream, but information is coming downstream. I'm trying to keep it upstream, and I already got the music coming downstream, okay? Upstream, downstream, don't forget to get your canoe! Yes. Okay, time to learn, guys and gals. Time to learn. Flick that switch and you all brain molecules. Okay, ready to learn? You guys ready to learn? Let's do this. Okay, wrapping around an unsigned integer, right? Remember unsigned? If it doesn't have a sign, right? Well, signed means minus plus, okay? If it's unsigned, that means they're dropping the negative, right? So I'll just bring up the little visual that I usually bring up here for you guys and gals. Okay, I'm gonna try to find something better, but there you go. Actually, I'm gonna keep it like this because I noticed that some of it gets blocked out. Okay, float takes require it. I guess I'm trying to use the proper wordage, right? I don't like using incorrect words, but float allocates 4 bytes of memory, and double actually allocates more. Okay, as you can see, the range for double is exponentially greater than float is. Okay, but float can handle a lot of very large numbers as well. Okay, again, take note that these are decimal values when we're talking about float and double. Okay, so going back, let's continue reading. Okay, right, signed, right? If it's signed, it has the negative, right? There's a bit, I believe it's a bit, to store that negative value, because that actually is, you can look at it like a character, right? It's a character too on your keyboard, guys. So it takes up some memory space too. So that's why the numbers here at the back end are different, because basically one's for the sign. It's weird how it takes it off the positive end, but that's fine. That's what it looks like to me, right? So here it's 8, right? These are supposed to be commas. Okay, essentially this is 2 billion, 2.1 billion essentially, but it allocates that 1 byte for the negative. That's why it's 7 here. Okay, if you're wondering, these numbers here, values, refer to the ASCII table. I'll bring it up. You will see this. I'll pop this up every once in a while as well. Okay. ASCII table. We only really care about the middle one. All the other stuff is just Russian gobbledygook and Call of Duty servers. I say that because, I used to grind COD 4 Modern Warfare 1 PC. I was on the hard grind. Shipman was my favorite grind, but if you checked chat, because of course you could type. Just Warzone has that stuff too, where people could type. But yeah, it would be all this kind of nonsensical extended character stuff. So that's why I call it Russian. I don't know. Slapping Russians on Call of Duty. Good times. I'm not scared to say that because, well, they're already trying to kill my people, so. Right? All right, let's move forward. Continuing on, trying not to go on a tangent. So here we go. That unsigned long integers have a limit to the values they can hold. Is only rarely a problem, but what happens if you do run out of room? Okay, when an unsigned integer reaches its maximum value, it wraps. Okay, so take note of that key word. It's not really the coding lingo per se, but it is a word that you have to understand. Okay, and I'll explain it. I'll do my best to explain it clearly here, as simplistic as possible, right? I'm not treating you guys like dummies, okay? Please understand this. I already know you're intelligent people. You're here learning what people consider to be a difficult coding language to learn, okay? So you're not dummies by all means. I'm just gonna tell you straight up. Okay? All right. So the word is wraps, right? Wraps. What does that mean? What do they mean by it? Wraps. How does that? What wraps? It wraps. Let's find out. Okay, here's an example. Much as a car odometer might. So I don't know. Some of the newer vehicles are all digital, but the old school cars. I love old school muscle. They were analog. Okay, I don't want to go on that tangent either because it's really sad how many of these beautiful cars got crushed and destroyed by the rules. It's really pathetic. It sucks. But anyways, to move on. So the odometer wraps, right? I don't know if you ever seen that, but it did because I forget how many digits it was. There was one that was allocated to be a decimal value, the tenths place. Which would have been the furthest right, and then it had I think 5 or 6 main digits, and then that 9999999 it would pretty much wrap, right? Anyways, if you ever seen, like, you guys have heard Ferris Bueller's Day Off. I know it's an old movie, I know, but that's what he was doing in the car scene. That's why it was jacked up. Because he put the vehicle in reverse because he was trying to rewind the odometer. You have to see the movie. It's a classic. I'm telling you, there's no school like old school. We were the cool school. All right, where R is. Cool school, baby. Good times. That's funny shit, to be honest. Sorry for swearing. Beep! Oh, dang, I put the beep in the wrong spot. Whoops. Why doesn't YouTube have a beep sound? What's up with that, YouTube? Like, who did you leave in charge to change the video editing software? It used to be great 8 years ago. I could take 2 videos and actually merge them and mesh them together and do like cut edits and stuff. And then they let some new clown, some newbie make their decisions and change things. You can't even do anything in it anymore. It's useless. Like, there's some stuff you can trim or whatever, but you can't merge other videos. I don't want to mean to go on a tangent. Not all of us have parents say, "Oh, parents, can you buy me some video editing software?" I'm a dad, man. My kid comes first. Food, groceries, bills, rent. If I have any left, it's gasoline. God. All right. Struggle is real over here. Not crying or complaining, but just saying. All right. I need to stop. I need to keep going, but hopefully you're getting a good laugh because that's kind of the goal here. All right. Let's see. Okay. What happens if you try to put too large a value into a short integer? Okay, here's the question. We're done with type defs, guys. Again, you could use it if you like. Check out the last video on that. We talked about it. I'm not going to continue anymore with it. That is it. Okay, I'm going to go like this. Home Shift B, let's build it, let's run it, make sure we're good. All right, let's go. Perfect. Okay, let's type some code. Unsigned, we're gonna use, so guys, right, take note. Okay, take note. I'm gonna pop this up quickly. Commonly, I'm going to say commonly, I don't know if that's using the right word or not, but commonly the main data types, these are called data types, are char, int, float, double, bool, which is not in here. Apologize that bool isn't, but bool's another data type. And those are the main ones, okay? So, but this course outline, it's a bit older that I'm going through, but no matter, it's okay. terminology, theory, all that stuff, it's all the same. It hasn't really like changed per se. Like basic theory, coding theory, and that's all the same, guys. Okay, so we're not really missing too much. Things do change, but you just kind of have to be up to par with technology, if you will. So my point is, this course that we're doing uses the, unsigned shorts, ints, and all that sort of stuff. Okay? You do not have to do this. Okay? It's probably going to ask me to initialize, so I'm going to do that. Quick coffee. It's great to have you guys and gals. Appreciate you being here. I like doing that now. It's funny. Okay. I think we should be good. What's unsigned short int? Let's so we have it in front of our face, okay? Whoops. That's fine. Unsigned short int. 1 byte, 0 to 65. 1 byte, 0 through 65, 535. I believe that's what it was. That's your range, okay? Allocates in memory. 1 byte, range is 0 to 65, 535, right? Okay, good. All right. There we go. So now you have an idea, right? It's in front of our faces here. We know. Okay? That's for unsigned short int. Let's type small number, and I can technically allocate it to 0 being a starting value, because the very first number, again, it's unsigned. That means there's no negative, right? That's kind of why we went into that. Okay, we're going to make it equal to the last value. Okay, 65535. Boom. Okay, so that's the top range. This is minimum, maximum, right? All positive values. Okay, positive integers, right? Okay. Hopefully you guys didn't fall asleep in mathematics class. All right. Math is great. I'd rather learn math than English. Okay. I think proper grammar and spelling is important. Writing grammatically correct sentences, I feel also that's important. It is. I'm not, bashing on, like, it's good to know the difference between your and your, right, in a sentence. Like, for example, your. Anytime you see an apostrophe, that means 2 words. Okay, what does your mean? Well, it means you are. Okay, simple stuff, right? So if you see an apostrophe, it means 2 words. That's what it means. Okay. Anyways, this is an English class. But my point is, I couldn't write an essay to save my life. I can't even write a book. I need literally a ghostwriter. I have all the information I need to write a book and publish and release a book, but I need like an editor. Okay? I'm not saying because I make spelling mistakes. I can spell. Spelling I did fine in. It's just the essay part, intro, conclusion, body, all that, the organization stuff, and yeah, it's just, for a lot of people, that's their strength. Okay, it's not mine. Okay, calculus was my strength. Mathematics is my strength. Okay. All right, let's continue. So, small number. Guess I'll type it up. And a little more typing, a little less going on and on. Okay, there we go. Okay, so here we're standard. See how I hope you've been following the series, guys. It's great if you have been. You guys are all legends, every single one of you. I'm not going to continue repeating theory and stuff. We're trying to move forward here. If you missed out, well, I'm not trying to be mean, but I recommend you go back to wherever you were at the last part of the series and just kind of continue. We're gradually going step by step here. That's what we're doing. Okay, string literal, returning the value. We're asking for information from the RAM, essentially. Oh, they got okay, there's something else I have to explain here. Because they got a new symbol here that they're going to bring up, which may confuse people, but don't let this confuse you guys, okay? Let's see if I can find it here in my notes, my operator symbols, so that we could talk about that quickly. I don't want to bring up stuff and you not understand what it is, okay? Bear with me. I'm just kind of scrolling through here trying to find it in my 138,346 character document. It's basically my novel. Okay, we're looking for, yes. What would be an easier way? Operators. I'm looking for the operators. There's urinary operators, the assignment operators. I do have a table of contents written up, but it's, of course, I have to be in my program for the line numbers. Table of contents. I got to go back there again. I need a reference. Somewhere around, looks like it's around, bear with me, guys. I try to be as prepared as possible, but sometimes we got to kind of jump around a little bit. Data types, I just literally seen it here in my table of contents, and now I'm like, I can't even find it. Wow factor. It's not at the bottom. It is too. Okay, it's way at the bottom. Somewhere above, around for loops, and after there is bug in the O stream. I'm gonna kind of go here. I think I'm close. I'm just kind of guessing here, guys. If I had my I actually have to open up my my solution here in Visual Studio. It has, obviously I use this as like the line number for the table of contents, but because I'm looking at my notepad, I don't have those line numbers, so I have to kind of guess. Oh, I think I'm getting close. Arrays. I think we're getting close, guys. Okay, is it here? Yeah, increment operators. Here we go. The urinary operators, which kind of sounds like a funny word. It's not urinary. Just jokes, guys. It's It's called the unary operators, increment and decrement operators. Okay. You have your assignment operators like the equals. For example, we have all these different operators, comparison operators, equal to. Of course, we have the arithmetic operators, right? I probably would go over these again in the future, but right, we all know about majority of these, right? For mathematics, we obviously know our comparison operators from mathematics, less than, equal to, greater than, equal to, typical stuff, right? But they have another C++ is there's a thing that they say it's I forget what they call it, but you have C language, which was kind of the original, and then you have C++. C++, that's what the plus is. It's the increment operator. Okay? So incrementing, really all it means is +1, guys. You just got to keep it simple in your mind. Okay? And I'll explain here, and of course there's pre and post, but we'll talk about that another time. Because you could actually put your plus in front, which is called pre. Okay? But I'll go over this in the future. Stay tuned, guys. So all it means is, like x plus, all it means is x equals x plus 1. So really what we're doing is we're going x plus 1, and then we're storing it back into x, because this is how variables work in coding, okay? Normally in mathematics, we would have y equals x plus 1. But it's, you just got to differentiate mathematics. Mathematics is mathematics, right? But with coding, we could actually say x equals x plus 1. So that's all the increment operator means. Okay? Just as a quick kind of breakdown on what's up. So we could write this same statement as small number equals small number plus 1. They both do the exact same thing. Okay? So we're basically, again, guys, it's the variable that stores the information, right? Just like the house number concept. Okay? Int house 1 equals 5. Right? The house has an address, right? AKA memory address. So the house has its own address, which is a location in memory, our RAM. Okay? This value 5 is, we can look at it as 5 people. There are 5 people in this house. So the value gets stored into the house. But for the computer and the compiler to access that information, it needs to know the address. It's no different than a delivery person. It needs to know where to go to make that delivery, right? Okay? I know I went over that again. I've already explained it, but I'll quickly explain it again. I'm not going to do it over and over and over again. Again, it's great to have you watching. And pay attention to these little details. A lot of certain things, certain concepts. Guys, excuse me. I try to reiterate and maybe over-explain, but they're kind of important. All right? Excuse me. All right. So this line. So we're taking this value here, which is inside. This value is stored in here. So if you want to see, I can do this. Watch. Okay. Now, right now, I set a position where we're going to start here. Right now, we haven't actually gone into this line. So small number has the value stored 0. Okay. If I jump to the next line, step over, it's called. Now we stepped over, so if we hover over small number, now the value of small number in memory is 565535. Okay, line by line, guys, remember? So now we're at this line right now, which we don't need to go into, but just so you understand. I just realized that the console actually pops up when I do that. Okay, I gotta be aware of that because you can have linker issues if you try to run the console again. Okay, so we're gonna increment this number 65535. What's gonna happen? Well, okay, so first we're gonna display it before the increment part. Okay, I'm just gonna go like this. You can take notes of this if you want, and I'll just go like this. Means the same thing. Okay, we're gonna add 1 to the value and then store it back in. That's what happens. That's the magic under the hood part. Okay, guys? All right, now, so we're gonna print it to the console before we make the change. So we're gonna make the change, and then we're gonna display that value after the change. Okay, that's what's up. All right, let's run it. There we go. So first it printed the actual value, right? Which is correct. That's what's stored. But now, and then we went 655,535 plus 1. It equals 0? What? Equals 0? Why does it equal 0, Bob? Let me explain. The keyword is wrapping. Okay, I'm going to do it again. I'm just copying the exact same thing. So we're going to increment it again, one more time. Remember, it's stored, so just so you guys understand, line by line, right? So here, we're printing it. It's going to give us this value. We're incrementing it by 1, okay? Then it returns 0, right? And then we increment it again. What's it going to do when we increment it again plus 1? Well, what's 0 plus 1? Well, if you weren't sleeping in mathematics, we all know that 0 plus 1 equals 1. That's mathematics 101, right? Let's run it, and then I'll show you what's happening here under the hood. I keep doing that. Control-Shift-B, Control-F5. Boom. And that's exactly what we get. So we're getting 1, and if I keep doing it, I could go on and on. I could keep incrementing it, but we would get 0, 1, 2, 3, 4, 5. I could keep going on until we got back to actually this number, right? Which is 65,533 more times, which I don't want to do, okay? So what's happening? Okay, so what is happening? Now they have a little bit of an explain here, but I'm not going to explain it. They're talking about Pentium 4s and Windows XP. Windows XP was so good, guys. It was so good. That was my kid. I got him introduced into Roblox using Windows XP. He loved it. Man, I couldn't even get him away from the keyboard. I was teaching him how to be a keyboard gamer when he was pretty young. Good times. Father and son quality time. Okay, so I kind of explain what's happening line by line, right? So what is happening? All right, so I'm going to bring this up here. Right, I'm going to bring this up and I'm going to explain. So we did this one here, right? Unsigned short int. This is probably the easiest to explain, but it all works the same. Okay, so if you look, we're starting at 0, we're ending at 65,535. The keyword is wrap. Okay, wrapping. Okay, here's kind of a visual, and this is really kind of the best way to explain it. Now, don't look at it like a clock. Okay. Let's see. I don't know. Where's 0 going to start? I don't know. Is it clockwise? Hang on. Let me see. Okay, let me read this. A signed integer is different from an unsigned integer. We're actually getting into this part right now. In that half of the values you can represent are negative. Of course, we did unsigned, right? So we don't have any negatives. But instead of picturing a traditional car odometer, you might picture a clock, right? Which probably helps, makes more sense. In which the numbers count upwards, moving clockwise. So clockwise they increase. Downwards, moving counterclockwise. So they cross at the bottom of the clock face at 6 o'clock. So what they're saying is, if we let's use this one for an example, sign short in, because there's smaller values, but it all works the same. The theory and the logic behind it is this. It's the same, guys. Okay, let's go with this number here. Okay, we're gonna start at 0 because 0's in the middle, right? Integer math, guys, right? All negative numbers starting from 0. 0 is the center. All negative numbers go infinitely to the left. Negative numbers. All negative numbers go infinitely to the left. And from 0, all positive numbers go infinitely to the right. Okay? So they're saying 0 is here. I think that's correct. All positive numbers would all go all the way to here and end here. So we're going to be stopping at 32767. That's going to be at the 6 o'clock. I can't write it here, but that's what it is. So all positive numbers from here, clockwise, stopping here, okay? And then all negative numbers, we're starting at 0, and it's wrapping. So the negative 32768 also ends at 0. So if we're going from here, if we're here and we're going +1 or -1, that's where the wrapping's happening, right here at this location. That makes sense, guys? I hope so, right? So if we, let's see, 0 to 255. Essentially with this one, it's similar, except we don't have any negatives, right? We don't have any negatives, so we would be going 0 all the way and wrapping all the way around, right? Because there's no negative numbers. So we would be going from 0 and wrapping all the way to 65535. Okay? So with that said, let me just try to click the right one here. So when we go, we're at 65535. If we go plus, it starts at 1. Remember, we're at 0 here. 0, 1, 2, 2, 2, 2. If I actually subtracted, we should be going backwards. So let me show you. I hope that makes sense. So check it out. I'm going to get rid of this, and we're going to go minus. Okay, I'm going to build this. So we went from, let me just build it, and then we'll run it. That's the logic behind it, guys. Okay, that's what's happening. Okay, that's why you have to pay attention to this. So look, I went minus. So we went forward 1. We ended up at 0. We're basically at the 12 o'clock right now here, right? We're just hypothetically speaking. I mean, they're kind of at the same location, but let's just pretend for all intents and purposes. All right? So we're at 12 o'clock. We're plussing 1. We essentially get to 0 because the number does start. Our range is from 0, right? So closing this, if I go back to plus, we're going forward, right? Clockwise. Right? We're going clockwise. So 0 plus 1. Now we're going clockwise on the clock, right? I'm going back and forth here a lot, bringing the information. So we're going forwards, right? Just ignore the clock numbers. But essentially, it's kind of the same thing, the same concept. 0, we're wrapping all the way back up. Again, we have no negative numbers with an unsigned, right? So now I'm going to go minus, minus, and then we're going to go minus, minus again, just so you can see what's happening. Whoops, that's an equals equals. Make sure you press the right button, guys. Okay, there we go. Oh, right. I better change the sign here because that's what we're doing. We're actually minusing. Right? And yeah, that's the other thing, right? So every time we go line by line, the variable is being updated in memory, guys. So the next line, well, just think about it. When we minus, we're using the last stored value in the variable, right? That's how it's working in memory, right? The value in memory is getting updated line by line. So it's going to use the most recent last known value. Okay? Guys, running. Look, see? Check it out. And there you go. That's what it means by wrapping. Okay, see, now we're going backwards, right? Because now we're going counterclockwise, right? From 12. And you can see, I'll keep going. I could show you another line. We could keep going. I'll do another one. So you can see. Just going like this, just to kind of so that all your focus can be on this, right? You see that? How we're going backwards? 5, 4, 3. So if we did the clock thing again, right, we're going backwards, and we would have to keep going. We would keep going. Eventually, we would end up back at 0, right? If we kept subtracting, right, guys? Makes sense? So that's how that works for an unsigned, right? It would be the whole clock because, again, there's no negative numbers. But with a signed, 0 would be 12 o'clock. I just want to close this. 0 would be 12 o'clock. Right? So all our positive values would end here. And all our negative values would end here. Okay? From 0. And then they would kind of wrap at this point. Okay? That's the difference. That's the subtle difference right there. Okay? I hope you guys get that. I wanted to explain it as simple as possible. If you want, I could show it going back up. I'll do it twice. So we're plussing again. So you can see we're basically starting at, that's our starting point, right? The 655, that's where we're starting at. We're basically at 12. And then we went plus 1, it took us to 0. I could keep going in the positive direction. We would be getting 1, 2, 3, 4, 5, 6. But in this case, we're going backwards. We're subtracting, right? We're subtracting. So we're going 5, 4, 3. What happened here? Why is that 5, 6, 5, 3, 3 again? That's odd. Oh, because I printed it twice. That's what happened. I'm going to delete that. Something happened. Yeah, okay, let me just go like this. I ended up copying it from the wrong spot. Let me just fix this up in code. So at this point, we're going positive, which is clockwise, right? At this point, we're going negative, which is counterclockwise, okay? Last known value. Run it again. Okay, there we go. It's fixed. Okay, right? So we're going minus. We're going clockwise here. We get to 3. I can keep going on forever, but just giving you a short demonstration. So at this point, now we're going clockwise. So we're going from the last known value clockwise. So you can see it increases. And we're going back towards 0. All right, I'm leaving it at that, guys. That's Computer Integers 101. Again, with computers, there's technically speaking a min and max, okay? And when we're doing mathematics, right, of course, all negative numbers go in the negative direction or left infinitely, right? When we're talking about mathematics and doing math problems. And in turn, right, 0 is the center. All positive values go to the right infinitely. So take note with computers, because I don't know, there's a min and max. It's just what it is. Okay. This is our counterclockwise value. Pretend 0's here. These are all our positive numbers, right? Make sense? I hope so. I'm going to leave it at that, and we're going to continue. Probably the easiest, most simplest way I could show you how that works, okay? So we're kind of going like that. On a number from 0 to clockwise, yeah, I've already kind of explained that. So just think of it like that, right? Just remember, if there's no negative, if it's unsigned, you're wrapping the whole clock. If you have negative values, well, all the magic's happening down here. Okay, at 6 o'clock. All right, there we go. Boom, boom, boom. And run. Okay, perfect. Okay, let's keep moving forward. I think that's a pretty good demonstration on that. You guys got this. Okay, I believe in you. So, I mean, I could continue on and on doing that and showing you, but it's all the same. Okay, I could do it with signed integers as well. It would still be all the same. Same concept, same logic. Okay, working with characters. Okay, we're getting into characters now, right? We're moving on. We're moving forward. Just, if you need a little more time, just review, search. You can search something to the effect of wrapping around a signed integer, C++, something to that effect. Demonstrating of adding too large a number to a signed short int, right? This is all part of the understanding what's happening under the hood. Like, let's say you're doing a program of sorts and you're working with a certain data type, and then you don't understand this concept and you're getting weird numbers, and then in your brain you're going to be like, what am I doing wrong? And you're going to be pulling your hair, right? Why are you pulling your hair? Well, because you know, I'm not saying you, but for the lazy person, if they cheated and shortcutted the system, now they don't understand what's happening under the hood. This is the concept. This is the main point here. Understanding what's happening under the hood. Okay? It's not as hard as people make it out to be. Working with characters, character variables, type char. All right, we're going to work with chars now. I've typed this a few times. Char letter equals A. Remember, it's always single quotes. Single quotes with a single character. The bits and bytes for a char. Let's look at that quickly. Bits and bytes for a char allocates 1 byte of memory. The range is negative 127 to 127 or 0 to 255. What does that mean? It means this. I guess 0, 0 to 127. These all have different purposes, but mostly we're going to be working with this. So really we're going from 32 to 127. Those are our main numbers we're going to be working with. We could print these values based on the ASCII code. Okay? We'll do some of that. It's fun. Good times. This is how the computers make the magic happen, guys, under the hood, right? If you're wondering how computers work, ASCII code. Right? It's key. It's like without ASCII code, we wouldn't be able to even type anything. It's so important. Okay, same thing. A keyboard would be non-existent without it. A keyboard would be useless without ASCII code, without the ASCII character set. Okay, type char are typically 1 byte, enough to hold 256 values. A char can be interpreted as a small number, 0 to 255. Now that I like to see. That 255 is common with IPv4 addresses and doing binary math. Excuse me, I don't want to get into that now, but that 255, oh yeah, it's a magic number too, as well. I mean, okay, so small number 0 to 255, or as a member of the ASCII set. The ASCII character set and its ISO equivalent, or ISO, are a way to encode, there's a keyword there, encode, or you've heard the words cipher and decipher. This is fun. This is where the genius is between ciphering and deciphering. This is where it all happens. I love it. It's good times. Are a way to encode all the letters, numerals, and punctuation marks. Computers do not know about letters, punctuation, or sentences. All they understand are numbers. In fact, all they really know about is whether a sufficient amount of electricity is at a particular junction of wires, right? Another reason why things get warm. You know, these two states are represented symbolically as a 1 and 0. By grouping ones and zeros, the computer is able to generate patterns that can be interpreted as numbers, and these in turn can be assigned to letters and punctuation. Bits and bytes, baby. So, like, I could get into some binary math a little bit, but you have 0, 0, 1, 1, 0, you know, that sort of stuff going on. Of course, it's 8 bits. 8 bits equal a byte. You know what I'm saying? Know what I'm saying? Know what I'm saying? Okay? 8 bits equal a byte. 1, 2, 3, 4, 1, 2, 3, 4. Okay? That's just to give you a general idea. Now, you don't really need to know this stuff, but essentially that's kind of how it's working under the hood. And then, yeah, I don't want to get into electrical theory, but of course you have transistors, transistor gates, and switches. Essentially, they're like little switches. On, off, on, off, on, off. That's why I think of bools like light switches. On, off, true, false, true, false. Okay. In the ASCII code, a lowercase letter a is assigned the value 97. Okay, let's look at that. There we go, right there. Okay, truth bomb right there. All right, so all the lower and uppercase letters, all the numerals, and all the punctuation marks are assigned values between 1 and 128. Okay, between 1 and 128. Between 1 and 128. Interesting. Null characters. Okay, so what they said was all the lower and uppercase letters, all the numerals, and all the punctuation marks are assigned values between 1 and 128. For me, just logically, like, I don't know why it's saying that. And additionally, 128 marks and symbols are reserved by the computer maker. Although the IBM extended character set has become something of a standard. ASCII is another way this is pronounced, ASCII table. Okay, so IBM, they brought up the word IBM. You can see the extended characters start at 128. For the basic standard American keyboards, okay, 32 to 127. Oh, 127 is right here, but I kind of put it in there anyways. All right, let's continue. Characters and numbers. When you put a character, for example, A, into a char variable, which we've done here, right? I've declared it, gave it a variable name, and you have to, when you're working with chars, you need these single quotes, okay? You don't go like this. This is incorrect. Okay? That's incorrect. Right? You can see it's ghosted. It's wrong. Okay? The punctuation is key encoding. Syntax, all right? It's important. All right. What really is there is a number between 0 and 255. Okay? So if I run this, let's have a look. Let's see what it shows us if I run this. I'm running the debugger, okay? We're not in the line yet. We have to step over the line. Okay, I'm going to step over. There we go. Letter 97. So, as a matter of fact, I should have looked at it beforehand. Okay, I'm going to close this. I'm going to run it again. Whoops, wrong one. Okay, right now it's showing 0. Okay, because we haven't, the compiler hasn't read the line yet. So just imagine, all right, stepping over. Now the line has been read. The value there in memory is 97. And the character there is A. Okay, stopping. Okay. Continuing on. Okay, so the compiler knows, however, how to translate back and forth between characters represented by a single quotation mark and then a letter, numeral or punctuation mark. Okay, we can put numbers in here as well because it's still a character on our keyboard, guys. Okay, you look at a keyboard, every single key there is a character. Okay, yes, in our brain it's a number. Okay, in a mathematical and number sense, but because we're using a char. Same thing with a string. If I type standard string, I don't know what it is. Here's where the hardest part is coming up with variables that make sense. I don't know. I'm just going to call it number for now, which doesn't make sense. Again, strings are double quotes. I could put an 8 there, right? A string can have one character as well, but typically it's one or more. Okay? But this is still a character. No different than writing the number 8 on a piece of paper. In this sense, if I type it here, int value equals 8, okay, that's an actual numerical value, an integer value. Here it's just a character. Here it's just a character. Okay, that makes sense? Again, and it's going to have a value because it's a character. All right, let me continue. We could use this for in a mathematical sense, right? For equations and values and doing calculations and what else not, because I love math. I hope you do too. How much time are we at here? I feel like this is going well. We're doing good so far. We got time. I'm trying to keep the videos around a couple hours. Hopefully that's fine for you guys and gals. Hopefully it's not too long. Again, teaching over here. Okay? That's the goal, to teach the subject. The compiler knows how to... The value-letter relationship is arbitrary. There is no particular reason that the lowercase a is assigned to value 97. Okay, it has to do with the binary bits and bytes. That's kind of how it works a little bit deeper under the hood, right? There's a little bit more magic going on, but all we really need is the gist or understanding of what's happening, okay? We need to know about this stuff. We need to know of it, okay? As long as everyone, your keyboard, compiler, and screen agrees, no problems occur, okay? We just want to see results. It is important to realize, however, that a big difference exists between the value 5 and the character 5, right? Just as I explained. Right? That's a character. That's a value. Okay? It's quite clear, right? You guys are smart. You know. You see it. Okay, they're using the number 5, for example. I have the number 8. Potatoes. The character 5 actually has an ASCII value of 53. So we can look. 53, character 5, right? It's a character still, even though in our brains it's a number. Yes, it's a number, but it's still, think of it as a character. It's a character on our keyboard, right? Look at your keyboard. There's the number 5 on there. That's it. You're pressing a character. Okay, see right there? 5 is 53. 8 is 56. You don't have to have these memorized, but you could do a Google search or whatever search engine you use. Search ASCII table, something to that effect. Okay? Or you could just screenshot what I just showed you there. It's up to you. I use Snipping Tool. Snipping Tool is great. Okay, let's see. And as much as the letter A is the value 97, right? They're all characters. You look at your keyboard, just think of them. It doesn't matter if it's a number. It doesn't matter if it's a quotation. It doesn't matter if it's a minus sign or a plus sign. Bottom line, they're still all characters, guys. Or chars. Okay, chars. We could actually for loop. We haven't talked about for loops at all. But we could actually for loop through all of them. So to see all the characters, so this is how you print all the characters to the screen from 32 to 127. I'll show you how in code here. Okay? We'll get into for loops. I'll talk about these more, but don't worry about what I'm doing here. Just ignore it for now. Okay? This is how a for loop is typed. I got the incorrect values right now. I actually, as a matter of fact, I could create variables for this. So we're going to have kind of starting values. All right. So just so you can kind of see the relationship. So I'm going to go, it's technically speaking an integer value. So I'm going to call it space, int space equals 32. I'm just initializing and declaring. That's all I'm doing. You'll see. I'm kind of being fancy, but that's okay. And 127 is delete. So I'm just going to go int del, that's good enough, equals 127. Okay, so all I've done is I've declared two integers. I've come up with my own variable names and initialized them. Okay, these are our values here. So from 32 to 127. All right, so now I'm going to use them here in our for loop. Okay, so we need a starting value. Int I, we have to declare it still in the for loop. I'll talk about this more. So this is our starting, okay, starting number. And we're going to go, we have to be less than, not equal to, but less than. Actually, yeah, that's a good idea. I could do that. What's that there? Let me just see. What's 128? 128 is that weird symbol. I'm not going to do that. I'm going to say, yeah, less than 128 still would work. Less than or equal to, I guess I'm going to have to use, because it does have to equal to it. To delete, in for loops, you have to use these colons, just as a heads up. And then here we're using our increment operator. So we have a start. This is for loops 101 right here. Start, end, and we have to keep looping. We have to keep looping. So I'm gonna go. I use pre, not post. Okay. So increment operator, but I use the prefix, not the postfix. Okay, so here we go. So now we're just gonna return to our console the chars. This is where we're being explicit, guys. That's what the parentheses is doing here. We're being explicit. Chars and then I. Okay, there could be a space. It's fine. And then I think, yeah, it does take it like that. And then we're gonna, is there a return 0 in the for loop? Sure. It's not common, but we'll see what it does when we run it. So we're just gonna so we're actually, this line here is gonna put it out to the console. It's gonna loop between 32 and 127 using the for loop. And then we're going to return the values basically on our keyboard. We're being explicit that we want char return. Okay, that's what the brackets are doing, being explicit. Boom. And it didn't do it. Return 0 into the... Why didn't it do it? Hold up. Let's go like this. Come on, work with me here. Char I. I do have another way of doing this. We'll see if it works. There we go, I got it. I just had to get rid of the return 0. The return 0 cleared everything. So there you go. You can see right here, if you look. That's why I was like questioning, why is there a return 0 in the for loop? Oh, wrong one. Right? If you look, our first character is 32. That's actually the space on our keyboard. Okay, and right here, here's proof right here that I'm trying to, there it is, that space is a character. Isn't that mind-blowing? Space is a character. Isn't that weird to say that in a sentence? Can you imagine rolling up to somebody? Hey, did you know that space is a character? So we went through all the characters basically on our keyboard, all the way to the tilde. There's the tilde, and of course it can't really display the delete button. The delete, really, well, we all know what a delete does. So I could have actually went less than delete, because delete's not really returning anything to the screen. It's just invisibleness, right? It's nothingness. It creates emptiness. Okay? There we go. Isn't that awesome? And that's how you, again, don't put the don't put the return 0 in a for loop. I looked at it, I'm like, why is he doing that? It must be an old school thing. Because it's not even an integer or a double or a float function. It's odd. So I questioned it in my brain, and I'm like thinking, I feel like I'm gonna have issues with this. But that's okay. We got it to work, guys, right? I'll run it again. It's right there. Boom. So there's your script for basically returning all the character values that are on your keyboard. Isn't that awesome? Isn't that fun? Pretty simple, right? This simple program prints the character values for the integers 32 through 127. Because technically speaking, I guess under the hood, I don't know, these are all, I imagine these are all 0 and 1 bitted somehow. Again, that's why I say there's other stuff going on deeper under the hood. But that's okay. This is all we need to know here, how to do this. This is all we care about. The listing uses an integer variable I, right? Here's where I said you'll see the characters I and J a lot. So why I said that is because it's used commonly in for loops, okay? Now, it doesn't have to be I, it doesn't have to be J, guys. You could use the first letter of your name. Let's say your name's Bob and Sally. Okay, maybe not Sally. Tom or Terry or Tamara. Okay? You could use any variable. And recommended that just use a single character for your for loops, okay? You can use names, you can. Okay, but what you're iterating through is typically a single character. Okay, let's continue. So here we go. I got rid of the return 0, so that's fine. Okay, I'm glad I got rid of it. We're going to do something else. We're going to printing characters based on numbers, take 2. Okay? So inside here, in our for loop, so I'm just going to copy this, and I'm going to go Control KC. So let me just highlight everything again. It's a shortcut, a short to cut. Control KU. Highlight. This is how you comment stuff out, sections of your code quickly. Control KC. Boom. Okay, and then I'm going to paste that, and I'm actually, again, this is here's a tip for coding. When you're actually making your code, if you don't want a line run, just comment it out. Okay? It's part of your testing, right? And your debugging. You could do that. Okay, nothing says that you can't. Okay, so what they have here is unsigned char, which is not really common to see. Unsigned char I is equal to 32, and I is less than, well, they have 128, but we're using less than 127. And then I'm using the pre-increment operator, so plus plus I. You'll understand why when I explain it in the future when we talk about increment and decrement operators. So stay tuned and I'll explain why. And I'll show you examples too. And then we're going to return I to the console. So let's see what happens. What does this do? Okay, building, running. Exact same thing. No change. Okay, exact same return. So we used char here. Oh, I know what it is. I didn't need to be explicit. That's the difference. My bad, guys. My bad. I was still being explicit. I didn't need to because really I'm being explicit here. Okay. And boom. Okay. It didn't argue it. I mean, if you're being explicit, the compiler's not going to complain too much. But same result. So the point is here is if you type unsigned char here, we've already been explicit as to what we want for a return value. Therefore equals, we didn't need to do this part, right? We didn't need to be explicit. This is being explicit as to what return type we want. Okay, that's what that means there. Okay, guys, that's the difference. Little subtleties. You'll be able to read code, guys. You'll be able to read other people's code, and then you'll look at this and you'll go, oh, I know what that is. I know what he's doing. Ah, yeah, cool. I like that. That's what he's doing. He's being explicit. Nice. I love it. Right? Pretty awesome, huh, guys? Every little thing, every little subtlety has a purpose or a function in each statement. It's doing stuff. Special printing characters. I've already kind of talked about these already, but we'll talk about it again. The compiler recognizes some special characters for formatting, right? So we've already done some of them, right? Right there are special printing characters. Special printing characters. Characters. Yeah. Right? For example, I've already showed you the \n and the \t. That's a couple of them. So that's what we're getting into now. Easy peasy stuff right now, guys. Isn't it? This is just gravy on your potatoes, isn't it? Nothing like gravy on your potatoes. Okay, let's see. You put these into your code by typing the \. Okay, the \/ is called the escape character, right? Okay. Followed by the character, right? Which is N, for example. N is new line. T is tab. Thus, to put a tab character into your code, you enter a single quotation mark. The /, the letter T, and then a closing single quotation mark. Right? So, I'm going to get rid of all this because we're done with that. And we're going to declare a char. We're going to call it a tab character. And it's going to equal to Remember, single quotes? The backslash in this sense kind of is, I don't know, it's not really considered a character. I don't know, I can't really explain the logic that behind it, or in the, what would the word be? The back end code? Right? Somehow they nulled this. I don't know what they did. I'm not sure. I never really looked at it too deeply, but backslash is actually a character too in our ASCII table, right? The backslash, isn't it? There's the forward slash. Where, there it is, it's 92, right? We could actually print a backslash to the screen. So, but in this sense, it's called the escape character. It could be a formatting thing where the program knows that you're using an escape character, okay? So the reason I'm talking about this is, remember how I said, I'm just gonna type this, okay? When you're doing single characters, a singular character, you use single quotes, right? You can't do that. I think it's going to complain. If I build it, it's going to complain about that. It didn't seem to complain. Let's see if it'll actually return it. Let me just see what happens. In my brain molecules, this is the way I look at the logic. I just want to return that. Let's see. It's probably going to just really prove me wrong here. I've never done this. I've always looked at single quote, single character. Let's see. It printed just B. Okay? If you notice, you see that? It ignored the first character. Oh, maybe that's what they do under the hood. Oh, the first character is negated. How did they do that under the hood? I don't know, but we just learned something cool today. Again, you're checking it out here on Whiskey Tango Coding. You won't see this anywhere else. Let's go. That's what the backslash. So the very first character is negated somehow. I was always wondering how that wasn't considered a character, when I know in my brain molecules that's a character on the keyboard. But I didn't overanalyze. I didn't throw myself into a deep rabbit hole trying to understand. I didn't care. Well, I cared kind of, but I just moved forward, right? It's called resilience and strength. Just moving forward, right? You just need to know about it, okay? No sense going down that rabbit hole. But that's cool. Wow. Things you learn. Who would have thunk it, you know? Who would have thunk it? I'll change this I'll change that letter to, I'm going to go B and then C. Let's check it out. It should return C. Let's check it out. Watch this. Let's go! Man, things you learn. Things you learn. You guys learned something here, okay? Actually, I learned something too. But I had a feeling, like I was already explaining, that that backslash is kind of like, yeah. Okay, so again, the concept is the same, guys. Single quote, okay, is a single character. C will return. I'm going to change this to, I don't know, an S. And we're going to get S, right? There's no leading character, right? So it's not going to be deleted. Okay, it will be returned to the console. See, S. Okay. Let's move forward. I'm just going to go like this. Snipping tool, just so you can see. I'll show you some of these other ones. Okay, so we have the \A, which is a bell alert. I'll do that one for fun. It's a Windows thing. It's kind of cool. \B is backspace. \F is form feed. \N, new line. \R, carriage return. If you ever done any typing, you know what a carriage return is. Like an actual typewriter, you know, the real McCoy. A \T, tab. A \V, vertical tab. Ooh, you could do that too. Some of these I haven't really done. I've done the single quote. So if you want to actually return, here's the tip, guys, right? Things to understand. Okay, if you actually want to return a quote, you have to use the / single quote. Okay, watch this. / single quote, right? Because if I just go single quote, the code's gonna break. It's gonna go, hey, what are you doing? What's up, Bob? You're doing something wrong. Okay, so if you want to return a single quote, you got to do that. Here we go. You're learning little things here, guys. These are all important. See? So that's how you return the character single quote. You have to use the \. Same thing with a double quote. Same thing. So, for example, STD. I'm just going to show you this quickly. I'm going to call it string literal. Good enough. Okay, again, string is a series of chars. And then let's say I had, let me just check something out here in the stream. Are we good on the stream? Okay. Hey, how's it going, viewer? Appreciate you being here. You're awesome, Sawsome. Thank you for dropping by, lurking and twerking. I appreciate you. So, I don't know. Hey, you in chat. Okay. What's good? Okay, so I'm gonna do that. So check this out. So as you can see, when we declare, now we're getting into strings a little bit, but I'll get into strings a little bit more. String is actually a class, guys. It's not a data type. I know in the beginning I was like, that's a data type, but no, it actually has its own class. Okay. So whenever you want to return like this string, for example, here, you see how I'm returning that? I have to use double quotations to do that, right? So that's what the double quotations do. We're telling the compiler, hey, we want a string literal. Okay, so I'm going to go like that. Hey, you in chat, what's good? ... So now if I actually want what's good in quotations, I have to go \quote, \quote. Check it out. Boom. I didn't tell it to print. Silly me. Okay. I'm just getting ahead of myself, guys. Okay, and then I want to return to the console the string literal. What I've done here is I've declared it, I've initialized it, but I haven't told the console to print it, right? Little things. Boom. Okay, see? Check it out. Hey, chat. Hey, you in chat. What's good? How did I get that extra quotation there, though? That's interesting. Ooh, that's quite interesting. Let me run that again. I've never seen that before. I was expecting it just to be here, right? You can see that what's good is in double quotations. That's how you do it if you want to return quotations or single quotes to a console. Okay, guys? The little things, the little details, syntax. Now, for some reason, I'm getting another quote here. I'm not sure what's up. That's interesting, but I'm going to delete that one. I'm going to build this. And as you can see, it's kind of hard to tell, but this is more yellowish. This is kind of like an off. It's kind of like, what would that color be? Like a pale? Like a peach? Like a pale? This is more yellow, right? You can see the subtle differences, right, with the backslashes. Again, I have my own theme in Visual Studio that I did myself. I do have a video on YouTube on how to create your own theme in Visual Studio. Okay. All right, so there we go. Oh, it gave an extra set of quotations. That's interesting. Now, let me just go like this. I'm going to get rid of that. I'm just doing some testing here. That's what I'm doing. See, the quotation is there. So I only had one single set of quotes. Right? I only have that. But it's putting the leading... Oh, whoa. Okay. Return. Oh, I know what it is. I'm being silly. I figured it out. I don't have... So, check it out. This is what's happening. You see here? I'm returning this to console. Okay? There's that extra leading quote right there. Okay? So, I need an enter. Is what I need. So, I'm going to go like this. Check it out. Okay? Things that you learn, right? Again, it didn't take me 8 hours. I didn't waste 8 hours of my boss's income and day trying to debug a simple line like this, okay? There we go. See, I just needed an enter. There we go. That's all it was. I'm being silly. So silly. Yeah, so there you go. That's what was happening. No biggie. I was wondering where that was coming from, because for a second there I was thinking, well, does it actually put in the leading? I don't normally do these kind of things. You just need to know of it. But if you wanted to quote something, that's how you do it. Again, don't have this, right? Get rid of that. If I get rid of that and go like this, we're going to be fine. Oops. Oh, I got a linker error. That's what it is. You can't rerun until you close. Okay, good. Please go away. You got to be careful of that. Okay, see, no quote, right? Everything's good. Okay, this line here, these two lines here, so I declared, initialized, it's just a backslash quotation. I mean, I guess you could do that as well, right? And without the new line, you could have that leading quotation. I mean, you could do that. I mean, that works too. Again, it's better if you do everything inline, right? That's what you would normally do. But this works as well. Okay? Boom. All right. There we go. Hopefully you can see that. Let's go. Drop the yays. What do you think? Why not? Checking the time here. We're just about finished, guys and gals. Let me have a quick drink of coffee. All right. Here's the other ones that I didn't show you yet. So I'll just do this. There we go. Okay. So they have, see, I've already showed you this. So backslash double quote. You could also have a question mark. Backslash question mark. Double backslashes. So if you actually want a backslash, that's what you have to do, right? This is the escape character, and this is the actual character. Okay, makes sense? So to get a backslash in your code, you need to do a double. Octal notation. How that's used in code, I'm not really sure. I don't have an answer for that. And then they have hexadecimal notation. Maybe it has to do with a return type, like if you want a certain return type, I imagine. That's my guess. There are ways to, if you're returning floats or doubles, there are little tricks you could do to, let's say you wanted it to 3 decimal places or 3 significant digits. There's little tricks in code that you could do for that. Maybe we'll get there one day. Constants. That's kind of what we're getting into next. I might just leave it at that, guys and gals. But, so yeah, we'll get into constants next video or next week. Again, keep up the views, guys. I appreciate, you being here and wanting to learn and stuff. Like, I look at you guys as really, like, I don't know how to explain it. With a high regard, with respect, and I don't care what level of learning you are at. You could be a beginner. I still look at you with respect because you're here wanting to learn something like this and not wasting your time with toxic, stupid, dramatic, clickbaity, lying, dramatic, toxic, crappy waste of your life in videos. Okay, you're here watching a learning video, and that makes you a legend in my books. Okay, all right, cool. Let's see if I can find my escape character stuff in my script here, and then I'll kind of share that with you. Yeah, I already have it. Yeah, so I've already kind of I have it here. It's part of my 138,346 character C++ informational. It's a book in my mind, which I haven't published. Unfortunately, I should get my act together again. Money is kind of what holds me back from doing things, because if I can't afford to pay for advertising or pay for lawyers or whatever, I'm just not able to. So I'm stalemated until things improve, like subscribers, followers, getting paid by advertisers, YouTube, or whatever. Okay. Your views, your supports, sharing is caring. I appreciate it all, every single thing that you guys do to help the channel. Much love. Let me see. I was gonna look up my GitHub thing here. Give you my GitHub link, because I do have part of my novel or my C++ book online. Which one am I looking for here? This one? Is it this one? I probably had the right one open. Here it is. Okay. GitHub. Okay. I'm going to put it at the top of this somewhere. Let me just put it in here. WhiskeyTango GitHub, and link, and there. Okay, and then I'll also paste it into chat here too as well, guys. Make it easy for you. And here. Okay, and here into chat. Boom. There we go. There's the link for you in chat on Twitch. I should get my act together. I think it's in the description of a YouTube video. My link for my GitHub might be there as well, guys. But I'll show it to you right here. Okay. Whiskey Tango, GitHub. Whiskey Tango coding, GitHub. All right. I have my GitHubs kind of organized somewhat in C# and C++. I'm actually a bit of a newbie with GitHub. I won't lie. I'm not going to cap. There is a specific way to use GitHub. You can actually, there's a link to GitHub with your IDE as well. You can actually download, you can find somebody's GitHub, you can download a project and all those sort of things. You can do that. Mine's not set up that way. Mine is more set up for like support as support. Again, my GitHub isn't set up atypically. I do apologize for that, but there is good information there for you guys and gals. Okay, like for example, when I was doing C#, I actually created my own color standards for XAML and what else not. It's there on my GitHub. So it's a kind of a support library thing. I actually created a colors library. So there's kind of that there. I don't really have any projects on there, but my code C++ novel is on there. I don't have all of it on there. I started to do it. I'll do more and I'll add more, but you guys are gonna have to let me know. Like, I don't know if you're reading it or not, right? So it's kind of like my C++ book on how to C++. Again, I'm gonna need an editor and that to kind of do things the right way. A lot of it, again, it's money. Money makes determines whether you're able to do things in life or not. For me, this is free teaching and helping you guys learn and grow, and I'm enjoying doing this. Hopefully I'm not too bad of a teacher. Some of you don't mind. You're watching. Keep up the good work, you guys. I'm trying to keep you positive and motivated, right? You can do this. You can do this. I believe in you. Every single one of you beautiful, intelligent people. That is it. Johnny Whiskey Tango Coding. I appreciate you. I will see you guys and gals next week. Have a great weekend. All right. Be safe. Much love. Take care and peace out, guys. Peace.